right, for number 21, we have a bunch of fast ones. So the first was limit as x goes to infinity, and we have 100x squared and we have an x cubed. So the degree on the bottom is going to be increasing faster than the top, so it's equal to 0. B is the limit as x goes to negative infinity of x cubed minus 3 over 1 plus x squared. Now this means that the degree on the top is increasing faster, but we're putting in it really doesn't exist, okay? But a lot of times we can say which one it does on end behavior, right? So if we're putting bigger, larger, and larger negative numbers, an x cubed will come out negative, so it's negative infinity. C is the limit as x goes to positive infinity of an x over a 5x, so that's an easy one, same degree, the limit would be 1/5. D is another negative infinity one, so we're looking at a negative x cubed or over a 7x cubed. So this would make it positive because it's a minus cube. And this would make it a negative because it's a negative. So it ends up being the same sign. So you don't really have to worry about positive and negative infinity when they have the same degree. So just do what it says. This is a -3 and a +7. So it was -3/7. And E, we have the limit as x goes to infinity of an x cubed over a negative x squared. Now, this would be going to infinity or negative infinity, and it's going, if you think about long division, if I turn this around to x cubed plus 1, and then I divided by negative x squared plus 2, I would have to have a negative x here. And so that would be a slope of negative going down, and so if I'm approaching positive infinity, end behavior would be negative infinity. All right, so that was 21. We got 2 more. Number 22 asks us to prove that the limit goes infinity of sine x over x is equal to 0. And we're going to do that using the squeeze, okay? Because remember, this is an alternating one, and this one would just be over infinity, so we have to have some other way to prove this. So what we're going to say, we're going to use the squeeze. So sine x has to be between 1 and -1. And then we're going to divide everything by x. So I get -1x has to be less than sine x, which has to be, these are less than or equals, less than or equal to +1 over x. Now I'm going to take the limit of this side, the limit as x goes to infinity of -1 over x is equal to 0. The limit as x goes to infinity of +1 over x equals 0. And therefore, oops, we forgot to divide that by x. Because of that, by the squeeze theorem, the limit as x goes to infinity of sine x over x has to equal 0, because it has to be squeezed between those two. So if that's 0, the limit, that one is 0 and that one's 0. So this is that whole function where I might have this function and then this function, and here's my sine x over x. I'm looking at this place, the limit as I get here is 0, and from this one is 0, and so my function has to be 0. That was 22, and let's do this last A and B of 23. Lastly, let's remember that the limit as theta approaches 0 of sine theta over theta, that is equal to 1, okay? And that is a theorem. Okay, go back in your notes if you don't remember that. So this was part A. So part B says, find the limit as x approaches 0 of sine 3x over x. Now, we need to have 3x over 3x, sine 3x over 3x. We don't have it, but we can multiply by 3 over 3. And so now I can say the limit as x approaches 0 of sine 3x over 3x times the limit as x approaches 0 of 3. So what I did was I used this 3x and this, and I was left with a 3 out by itself. So this is equal to 1 times 3, which is equal to 3. All right, now that was your review of limits. It was a lot. I've given you the Barron's review. I really want you to do them all. I know it's going to take you a while, but this is your last review of limits, and we haven't spent a lot of time on that. So please, please, please take your time, and I would be assigning this if you were in class or you weren't in class. This is what you would be doing. It wouldn't have taken the whole class to do this review, these 23 problems, and we would have worked on some in class, and then you would have had the rest for homework. Look, right now you should be doing 90 minutes of classwork and at least an hour of homework. That's 2.5 hours of calculus. It was what you normally had. I cannot reduce it in good faith, so if you want to do your best on this test. So please, you're going to have to say, this is what I was doing during school. Just because I'm at home doesn't mean I have to stop doing the amount of work I needed to do. Okay? Now, it's up to you. I'm asking you to do it. This is what I think you need to do. I'll be grading accordingly. But please don't give up. And like I said, this is what everyone before you did, and everyone after you is going to do. It's no more work just because you're at home. Okay, thanks.